Hello students, again a new day, a new thought, a new ambition, or you can say what should we do today? Like I thought, what should I do today? I thought, let me come back to my most favorite thing which I want, which is teaching and which is my passion. And now I took the lesson chemical bonding, and I hope the dear subscribers who are seeing my channel, they are getting some information for the last minute revision or the tips. The background of the thing already you have, you will just revise it if you go to the exam with the keywords. Welcome to the new students and to the old subscribers who are watching this channel. I select this lesson of chemical bonding because the previous lesson which I did was photosynthesis. Previous to that, periodic classification of elements, whatever I did. I am now focusing more on ICSE because I find the ICSE syllabus vast, very knowledgeable, and it is in depth. So you have to study in depth. So that's why we go for chemical bonding. Only I will tell you the things which you will keep in mind very systematically, because this is a lesson of drawing. You have to draw the structures of all the elements which you are learning for your exams. Your book contains many structures, many examples. I will be focusing on some of them. I cannot tell you the whole thing, it will be very big then. So I will just tell you the concept which you will keep in mind while doing the lesson chemical bonding, right? So welcome back again to this channel, the Science Geek. Now, in this lesson chemical bonding, what we are going to study is what is a chemical bond, how is a bond formed, what is the types of chemical bonding which is there, and what does it result in. So, three main things are there. If the ICSE book is given things very nicely, keep the book in front of you, keep a notebook and pen also with you to see and jot down the points. So first thing here will be, what is a chemical bond? What is a chemical bond? Now what is the need of chemical bonding? Why we should say the chemical bonding should be there? Say for example, this same bonding in other terms, in biology we call it as when two things combine. Say these are the two atoms. Blue pen is one atom, A1, the green one is another atom. Now they both have to combine. So they can combine physically, we can take Fevikwik and make them combine, right? This in biology we will call, when they will combine, which you read in cell division, crossing over. Got it? Chiasmata formation, biology. What about chemistry? How does chemical combination takes place? Bond formation takes place between one atom to that of the other atom. It depends how close the atom come together while forming a bond. This bond formation depends upon the valence electron found in the atoms combining to form the bond. Whether it is in the duplex state, and they want to form a bond in order to attain a stable electronic configuration, which is duplet or an octet. So this concept, the chemical bond, is formed by the atoms for the stability of the atoms. Got it? So you should first write, you take the example of the blue pen and the green pen, which I said. Now, so the first definition here in your ICSE book is given as, what you will write here, what is a chemical bond? The bond which holds two or more atoms together in a stable molecule, because an atom cannot exist independently, but a molecule can exist independently. That is the difference between an atom and a molecule. Okay, that is a chemical bond. Now, also, atom is the smallest unit of matter. This also you should know. And also your previous knowledge states that the atom has all the shells, and in all the shells there's a K shell, L shell, M shell. And within the nucleus, if you remember, you have the neutrons and the protons. And it is the electrons which are rotating in the shells which will be used in forming the chemical bond. Got it? Atom, the smallest structure of matter, the structure of atom, nucleus with the shells, and the valence electron participate in bonding. Got it? Now, what are the types of elements involved? If this question is asked, what are the types of elements involved in chemical bonding? As I said, there are three types of bonding. Ionic bonding, covalent bonding, coordinate bonding. So, if I say the types of elements involved will be mainly, we will now focus on ionic bonding, that is the electrovalent bonding, which I will say, are the metals and the non-metals. the metallic elements and the non-metallic elements. Now, the metallic elements is the rule. They have 1, 2 or 3 electrons in their valence shell. 1, 2 or 3 electrons in their valence shell, and they lose this 1, 2 or 3 electrons from their valence shells to become positively charged cations. And if you remember the lesson periodic classification of elements, and these elements are the alkali metals if you start from left to right of the periodic table. The left side of the periodic table contains all the metals. As you go to the right side, all the non-metals come. And the metals and the electropositivity decreases as we go across the period, your previous knowledge. So, metallic elements with a valence electron 1, 2, 3 lose the electrons to form the cations. Underline the keyword cations. Next, the non-metallic elements with the electronic configuration of 4, 5, 6 or 7. They have a tendency to become stable. How will they become? They cannot lose suddenly 6 electrons, 7 electrons. So, they will gain electrons except the 4 one, which is carbon. They will gain electrons to become stable and to form an anion. Cation and anion are the key words. So, losing electron and gaining electron. Okay. Now, so the chemical combination, if you see, are in 3 ways. If I have written here the words transfer, sharing and donating. So, transfer is the metallic element, say it has one valence electron X. This is a non-metal which will combine with it to take it to attain a noble gas configuration. So, transfer of electron from one to the another atom. Like you will study the examples of sodium chloride and magnesium chloride, there you will see it. So, that is an example of ionic bonding, electrovalent bonding, resulting into electrovalency. Another way to attain electronic configuration is sharing. Here the example will be of carbon. Carbon has 4 electrons in its valence shell, periodic table. It cannot lose 4 electrons to become a cation, C4 plus, and it cannot gain also 4 electrons to become an anion, C4 minus, because of the nuclear pull and the electrostatic force of attraction, the molecular force of attraction between carbon atoms. So what it has to do? Best way is to share the electrons which it has with the other combining elements. Therefore, carbon will form 2 types of elements, polar covalent bond and non-polar covalent bond, which we will see, okay? And here sharing will be there. A is carbon, here the A is carbon, and all the 3 B, say for example methane, CH4, it's an organic compound. And all the compounds like the saturated hydrocarbons, unsaturated hydrocarbons, they all show covalent bonding. Because of the sharing, because of the property of carbon. Carbon has the 2 unique properties, tetravalency and catenation. Here we are not talking of that, we are talking about covalent bonding. And there is a large difference between ionic bonding and covalent bonding. That also you will see. Last type of bonding which you will see here is the coordinate bond. The bond which is formed by only where the electrons are coming from an donor. Say donor, only one, and the donor has an extra pair of electrons. Say for example here, this A is nitrogen. Nitrogen's valency is 5. So how will it accumulate? It will have 1, 2, 3 here. Ammonia, say ammonia, nitrogen, and it will form with the 3 hydrogen. So 2 will still remain here. So it can still donate this extra pair to the another acceptor. So a donor is there and an acceptor is there. That also you will see to form ammonium ion. And then ammonium chloride. That will be the example you will see in coordinate bonding. Okay, so this was the introduction to the lesson chemical bonding. I hope I am clear till now. Now we will start with the what are the factors which are important for electrovalent bonding or ionic bonding. Okay. Now please take your ICSE book with you. You can see open page number 23 of your ICSE book where they have given you the properties which affect the chemical bond formation. This is a very important question for board exam. What are the properties which affect the chemical bond formation, right? The properties, I am just writing the keywords here. Now this also, the properties which affect the chemical bond formation. Now we are starting with ionic bond, but here the 3 important properties. Recap your previous knowledge. First is ionization potential. Next one is electron affinity. Third one is electronegativity. The three important terms. I hope you remember the definition of ionization potential, electron affinity and electronegativity. If you want to recapitulate, let me revise you the definition. What is ionization potential? The amount of energy required to remove a loosely bound electron from the outermost shell of an isolated gaseous atom is known as ionization potential. Got it? And this leads to the formation of cation. So the metals have, to form a metallic atom, the metal should have a lower ionization potential. Okay, lower. Okay, and greater the ease is to form a cation if it has lower ionization potential. Next important property is electron affinity. Recapitulate the definition. The tendency, what is electron affinity? It is a tendency with which the atom will form an anion, which is required energy to form an anion. So again, for this, higher the value of electron affinity, it is easy for a non-metallic atom to form an anion. Got it? To form an anion. So electron affinity increases across a period left to right. Ionization potential also increases across a period left to right. Keep in mind, across a period left to right, ionization increases, electron affinity increases also left to right across a period. Right? So now that is the role of these two. What is this electronegativity here? Electronegativity should be lower. That is larger. The electronegativity difference between combining atoms should be large. The sharing tendency should be large, because then it is easily the electron transfer takes place. So the three factors or the three properties which affect ionic bonding or electrovalent bonding are ionization potential, which should be lower to form a cation, electron affinity, which should be higher to form an anion, electronegativity should be again larger, so the tendency of sharing increases. This is this part. Okay, now we come to the next part of the lesson, that is, we now start the formation of electrovalent bond. Okay? Formation of electrovalent bond. Now there are certain terms here which you should write in your notebook, and they can ask in the exam. First is the terms which you should write is what is electrovalency, what are electropositive elements, what are electronegative elements. Electrovalency. Under electrovalency comes electropositive and electronegative. Okay. So for what you will write for electrovalency? The number of electrons lost or accepted by the valence shell of an atom in an element to acquire the stable electronic configuration is called as electrovalency. Okay. Now, what are electropositive elements? The metallic elements which are having a tendency to lose the electron and become a positively charged ion are known as the electropositive elements. And the process of losing electron from one atom to another element is also known as oxidation. So oxidation is lose of electron and reduction is gain of electron. That is formation of anion. Okay. So oxidation, like cation will be formed, the electron goes away, we say it is oxidized. Okay. And then what is, say for example, sodium Na+, calcium Ca2+, sodium loses one electron from sodium atom, it will become sodium ion. You will see now, sodium atom, sodium ion. Calcium can lose 2 electrons, valency is 2, CO2+. Magnesium loses 2, Mg2+. You can see all the diagrams are given. There are 3 diagrams which you have to keep in mind. You have to write the ionic equation, you have to draw the electronic dot structure and also the orbital diagram for all the ionic compounds which are there in your syllabus. Many examples are given in your ICSE book. You have to see all of them specifically. Now, what are the electronegative elements? Electronegative elements are the non-metallic elements which gain electrons and become negatively charged, known as electronegative elements. That is, they become anion. and this increases across a period, and they are the non-metals. Okay, and this process of gaining an electron in an atom of an element is called as reduction. So oxidation and reduction are opposite of each other, and when both of them take place at the same time, we call with the word redox reaction. Got it? Redox reaction, a very important types of chemical reaction. There are many types of chemical reaction. Combination reaction, displacement reaction, double displacement reaction, photolytic, electrolytic. I am talking about redox. What are redox reactions? When oxidation reductions takes place at the same time. Okay, like respiration in your body is a redox reaction. If you want to recollect, give an example of redox reaction. So now, and in redox reaction we get the anions like chloride, because group 1 is the most electropositive element and group 17, the halo group or the halogen group, are the most electronegative elements. If you recollect the properties which you had learned in the lesson, periodic classification of elements. Got it? And another term which you should keep here in mind is the Lewis symbols, which is given in your book. Okay, Lewis symbols. What is this Lewis symbols? If they ask you define Lewis symbols, what will you write? The symbol notation to represent the valence electron of an atom is known as Lewis symbol. The simplest notation how to donate the valence electron of an atom is known by the word Lewis symbol. Like for example, carbon. I want to donate. I want to explain. So this is the Lewis symbol for carbon. Okay. If I want to show for if I want to show for lithium, 1 electron, right? 1 electron. So this is the things which you have to now keep in mind. And now we will see the formation of sodium chloride. First thing here will be the conditions. Now, as I told you, the conditions required to form electrovalent bonding are this: ionization energy, electron affinity, and large electronegativity difference. Okay, so the electronic dot structure of the sum of the important electrovalent compounds. First, you should keep in mind best example is NaCl, sodium chloride. So now, sodium, if you take it, sodium, atomic number 11, distribution 2, 8, 1. Got it? Sodium. Chlorine. So this sodium, when this is sodium. So this sodium, if it has to donate its electron, K shell, L shell, M shell. Okay, 2 electrons in the K, 8 electrons here, 3, 4, 5, 6, 7, 8, and only 1 big electron in the K shell. This is sodium. Okay, it will now give it, okay, to what? And it will become Na plus. How it will become Na plus? If they ask you to draw, again you will draw this, 2 here and 8 here, 1, 2, 3, 4, 5, 6, 7, 8, K, L. So this is the nucleus, and in the outer shell is there, but the electron is not there because it has gone. And sodium is now, electronic configuration of sodium ion is now 2, 8. It has attained stable electronic configuration. Now that one which has gone, we take the example with the another compound with here is chlorine, which is a non-metal. So chlorine, atomic number is 17. We write as 287. So here again 1 electron, that is K shell, L shell 1, 2, 3, 4, 5, 6, 7, 8. You have to count and write. And the last shell is again having 7 electrons, 1, 2, 3, 4, 5, 6, 7. 7 electrons. So this 7 means it has to become stable, noble gas configuration. So what it will do? It will take 1 electron from here in sodium and it will become an octet. 1, 2, 3, 4, 5, 6, 7, 8, and it becomes 2A8. This is chloride ion, anion. Got it? Na plus and Cl minus, anion. So what you have to now do here is you have to write the equations given in your book. Na loses electron, sodium loses electron, it becomes Na plus electron. Chlorine gains the electron and becomes Cl minus. Got it? And Cl minus. This, if you have to show in a straight line, how will you show in a straight line? This, if you have to show in a straight line, what you will do here is Na, it has to lose this extra electron. Cl, 1, 2, 3, 4, 5, 6, 7. Cl, 7 electrons here in a straight line. What it will form? Na is losing one. Na is losing one electron. See, Na is losing one electron, Na plus, and Cl will take this extra electron. So it will become Cl is dot wala 1, 2. I make big dots. 1, 2, 3, 4, 5, 6. One extra dot 7. And this x1 is, it will have this x here, and it becomes negative. Got it? Negative. And this is sodium chloride. That is, now the sodium ion is 2,8 and this is 2,8,8, which I showed you here. Yes or no? This is the orbital diagram and this is the electronic dot structure diagram. So you should now keep in mind orbital diagram and electronic dot structure, and this one was the loss and gain of electron from cation and anion. I hope I am clear here with the example of sodium chloride. Like this will be the example for magnesium chloride in your textbook. Then will be the example of calcium oxide, potassium chloride, and many examples are there. So you should take it with this lesson is a very interesting lesson. Keep drawing and writing on your own. There are 3 steps here. I think this is clear to you, right? Electrovalent bonding, electropositive elements, electronegative elements. They result into the factors contributing for them are ionic ionization potential, electron affinity, electronegativity. Now, next property is, now the next type of bond formation is covalent bond. Now what you will write for covalent bonding? What answer you should write here? If they ask you define covalent bonding, what will you write? A chemical bond formed by mutual sharing of electrons between combining atoms of the same or different elements is called as covalent bond. And the bond is generally formed between 2 electronegative elements, non-metallic elements, because there is no transfer, there is only sharing. The molecule which involves this kind of bonding is called as a covalent molecule. Got it? And the number of electrons shared by an atom in order to complete its octet is called covalency of the atom. And for example, formation of chlorine molecule. For example, we take the formation of chlorine molecule. Chlorine 1, 2, 3, 4, 5, 6, 7. Chlorine plus chlorine 1, 2, 3, 4, 5, 6, 7 will form Cl2. How will it form Cl2? It has to form Cl2. That is Cl. They will combine with each other. Both of them will combine with each other, and 1, 2, 3, 4, 5, 6. 7th one has gone here. 1, 2, 3, 4, 5, 6. One has come here. This one is known as a single bond. If one electron is coming from one side, it forms a single bond. If 2 electrons are coming, it forms a double bond. If 3 electrons are coming, it forms a triple bond. So covalent bonds are of 3 types. Single covalent bonding, it is formed by sharing of electrons, 1 electron from each side. For example, HCl. Okay, then HCl, even chlorine. Next one is double covalent bonding. Say if you take the example of oxygen. Oxygen when you will see oxygen valency will be what? what will be the valency of oxygen? How you can say 1, 2, 3, 4, 5, 6, atomic number 8. So 2, 6. So you have to show the bonding of oxygen as oxygen. Oxygen, oxygen. This is one oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When it has to combine, what it will do? It will combine like this. This two will come together. 1, 2 from here, 1, 2 from here. Here, the another one, the remaining will be there. 1, 2, 3, 4. 6 has gone here. This is 1, 2, 3, 4. So 2 electrons are coming. So therefore double bonding. Got it? Oxygen. So single covalent bond, double covalent bond, and the triple covalent bond is, say for example, ammonia, nitrogen. Valency will be 5, atomic number 7. So it has 3 here. It has another nitrogen. It has 3 here. So this single part will combine. This both has to combine. This part with this part combines. So we get triple. Single, double, triple covalent bond. Got it? 3 types of covalent bond. Now, another important property which you should write here, which they will ask you, how many types of covalent compounds are there? The keywords are, there are 2 types of covalent compounds, polar and non-polar. Polar and non-polar. Polar means polarity. Non-polar means when it doesn't have any polarity. So the polar covalent compounds are defined as, first you should know what is a non-polar covalent compound. When a covalent compound is formed between 2 atoms having almost the same electronegativity, then the electrons are equally shared between the 2 atoms. There is no much difference in their electronegativity. The electrons is properly placed, equal sharing. There is no much pull. Both of them have almost the same electronegativity, and the electron is equally shared. So that is known as non-polar compounds. Thus, the shared electron is situated exactly between the 2 identical nuclei, and this type of covalent bond is known as non-polar covalent compound. The examples are hydrogen, chlorine, oxygen, which you saw now. Now, what are polar covalent compounds? The examples will be water, HCl, and the values of some of the electronegative values are given in your textbook also. Now, the polar covalent compounds are when a covalent bond is formed between 2 atoms having significant difference in their electronegative values, and the shared pair of electron is shifted to the more electronegative atom. Okay, and the values of them, some of them like HCl is given in your book. HCl, the electronegativity of water, HCl, all is given in your book. You can just see that page. Refer to page number 32. Water, ammonia, polar covalent compound. Example is water. Another example is ammonia. And then this is 2 examples very nicely given here. You can see the examples given there, how they form polar covalent compound, water and ammonia, the 2 examples which are given there in your book. And for example, in water, the electronegative value of oxygen is 3.5 and that of H is 2.1. That is due to this large difference in the electronegative value, the OH bond in water molecules are polarized. We can say the polarized. Like this examples, they can ask you, name 2 compounds which with their values. You can give one as water and one as HCl molecule, where H is having 2.1 and chlorine is having 3.16. And we show this polarity as with this symbol, H plus and Cl minus, with this symbol. The bond formation is shown in your book. Formation of hydrogen molecule I showed you, chlorine molecule I showed you, electronic dot structure of 2 I showed you, hydrogen, chlorine, also nitrogen I showed you. And if you want to see the bond formation of water, for example, water. For water it will be, hydrogen has 1 lone pair of electron, and oxygen will be having 1, 2, 3, 4, 5, 6. Oxygen will be having this, and how will we show this? 1, 2, 3, 4 and 3, 4. We should show this one here and one here, like this. And you can see, and when you will see this, H2O is the formula of water. This plus with one more hydrogen will be here. Dot one is hydrogen, the X one is oxygen, and when they will combine, you should see how the structure is formed here. Hydrogen ka circle and with oxygen ka X, and here another X goes here, iska dot, and this is H. This is H2O. I think like this it comes. This is an example of polar compound water where polarity is there, told you. Another compound which you can form for a non-polar compound which doesn't have, very simple and interesting it will be, you can see and form carbon tetrachloride, CCl4, carbon with 4 electrons in the center, carbon, and Cl will be at the 4 sides, Cl, and you have to show it with a separate chlorine. Chlorine is having 2H7. So chlorine ka how it will show? 1 here, 1, 2, 3, 4, 5, 6, and this is the lone pair of electron here. 1 here, 1, 2, 3, 4, 5, 6. For this one also, here 1, 2, 3, 4, 5, 6. For this also 1 here, 1, 2, 3, 4, 5, 6. CCl4. So when you draw in your notebook, you should have a pen, a red pen, blue pen or pen, pencil, and you should do it very nicely so that the examiner gives you proper marks. So carbon tetrachloride, water, ammonia, H2O, and chlorine, fluorine, all not fluorine, and oxygen I showed you. So now this was the covalent bonding. Now you should also keep in mind the difference in their properties. This also they will ask you. A very good table is there on page number 34 where they are giving you the properties of comparison between covalent bond to that of ionic bond. That is the next part. And then I will come to last one will be coordinate bonding. Okay? Water. For water it will be hydrogen has one lone pair of electron, and oxygen will be having 1, 2, 3, 4, 5, 6. Oxygen will be having this, and how will we show this? 1, 2, 3, 4 and 3, 4. We should show this 1 here and 1 here, like this. And you can see, and when you will see this, H2O is the formula of water. This plus with one more hydrogen will be here. Dot one is hydrogen, the X one is oxygen, and when they will combine, you should see how the structure is formed here. Hydrogen ka circle and with oxygen ka X, and here another X goes here, iska dot, and this is H. This is H2O. I think like this it comes. This is an example of polar compound water where polarity is there, told you. Another compound which you can form for a non-polar compound which doesn't have, very simple and interesting it will be, you can see and form carbon tetrachloride, CCl4, carbon with 4 electrons in the center, carbon, and Cl will be at the 4 sides, Cl, and you have to show it with a separate chlorine. Chlorine is having 2H7. So chlorine ka how it will show? 1 here, 1, 2, 3, 4, 5, 6, and this is the lone pair of electron here. 1 here, 1, 2, 3, 4, 5, 6. For this one also, here 1, 2, 3, 4, 5, 6. For this also 1 here. 1, 2, 3, 4, 5, 6. CCl4. So when you draw in your notebook, you should have a pen, a red pen, blue pen or pen, pencil, and you should do it very nicely so that the examiner gives you proper marks. So carbon tetrachloride, water, ammonia, H2O and chlorine, fluorine, all not fluorine and oxygen I showed you. So now this was the covalent bonding. Now you should also keep in mind the difference in their properties. The difference in their properties, this also they will ask you. A very good table is there on page number 34 where they are giving you the properties of comparison between covalent bond to that of ionic bond. I'm just writing you the comparison of properties between, draw a table in your notebook and write on one side ionic and on one side covalent. Okay, now open page number 34, last minute revision. Say for ionic bonding, what you will write, the state of bonding of in electrovalent compound, the molecules exist as crystalline hard solid, and the constituting atoms are the units are the ions. And what do they form? The force of attraction is very strong. Why is the electrostatic force of attraction very strong? Because they exist in the form of ions. That is why positive, negative, very strong force of attraction. And for this reason they have high melting point, high boiling point. And also for this reason they conduct electricity only in the molten state, not in the solid state. Because in the molten state ions are available, in the solid state ions are not available. These all properties are there. Then they can be electrolyzed. They show electrolysis, sodium and sodium shows sodium chloride, and it is known as brine, which we will study metallurgy, brine. Okay, and they are highly soluble in water. They are insoluble in organic solvents, and they show high speed ionic reactions. Now what about covalent bond? Covalent compounds, the state of bonding is covalent. They exist as gaseous, liquid or soft solid. And what are the constituent units there? Molecules. There the unit was ions. The force of attraction is very weak here. And what is the force of attraction called here? Van der Waals force of attraction. Very important, right? Van der Waals force of attraction. Now, and the molecules have very weak force of attraction between them. They are very less volatile, and they are highly volatile here. Which one? Covalent. And they are non-volatile, ionic. Then third is melting point, boiling point, low melting, low boiling. Then conduction of heat, they are bad conductors. Conduction and electrolysis, they cannot undergo electrolysis. Solubility, they are not soluble in inorganic solvent, but they are soluble they are soluble in organic solvent, but they are insoluble in water. Okay, and speed of reaction, they show slow speed of reaction, and they don't undergo ionization. This is, you should know the comparison. And the last property and the last type of bond which you have to keep in mind is the coordinate bond. The best example here is coordinate bond. Coordinate bond. Now, again you can see your textbook. The three questions here comes here. What is a coordinate bond? Explain the formation of coordinate bond with an example. So what is a coordinate bond? The bond which is formed between two atoms by sharing a pair of electrons with the condition that both the electrons which are shared are contributed from only one atom. That atom which will give, I told you in the starting, will be called as the donor, and the another atom which will accept it will be called as the acceptor, donor acceptor. So this is known as coordinate bond, and it is denoted by a single line. It is denoted by a single line like this. Here is the donor and here is the acceptor. And the best example here will be, we take the example of formation of ammonium ion. Formation of ammonium ion. Okay. Now formation of ammonium ion involves, for example, ammonium, nitrogen, nitrogen 2 5 valency 5 1 2 1 2 1 nitrogen. Okay, nitrogen. This is Lewis structure of nitrogen. Lewis structure of nitrogen. And hydrogen. First, hydrogen, what you will write for hydrogen with a separate pen? E. Lewis structure of hydrogen. First step. What will be the next step? You have to show their bonding between nitrogen and hydrogen. What you will do here? Nitrogen. It will form. To form ammonia. It is going to form now ammonia. How will it form ammonia? 1 and the green dot here for nitrogen. 1 is across. The green comes for the hydrogen. 1 here. The green comes for the hydrogen. 1 here. But still you will see 1, 2, 3. 2 are remaining as lone pairs. These 2 will be called as lone pairs. And this ammonia, H, NH3, ammonia. This is ammonia. Now, what about this is, so first you will draw the Lewis structure of nitrogen, hydrogen, then the lone pair will be remaining when you will form ammonia, and now you will form ammonium ion. Last step will be formation of ammonium ion. That is the same thing combining with H, and that you will show is as nitrogen, and the lone pair will be donated to hydrogen, the acceptor. The hydrogen will take that lone pair and it will become, the compound will become N with a positive ion, NH4 plus. And this NH4 plus can further combine with chlorine, which I am not showing you here. NH4 plus Cl minus will form NH4Cl. Got it? 3 steps. Very, very interesting and very nice. I won't take much time of yours. So I think I have given you a quick revision of the lesson chemical bonding. What is the chemical bonding? How it takes place? What is the need of chemical bonding? What are the types of chemical bonding? And what is their significance? What factors contribute in their formation of chemical bonding? Ionization potential, electronegativity, electronaffinity. Then we went for NaCl, the steps I showed you, and the properties of electrovalent bond compounds told you. Then we came to covalent bonding. I told you what's a covalent bond, what is covalency, what are polar covalent, what are non-polar covalent, some examples I gave, and then a comparison between both. And in the end we came to coordinate bond. What is it? Example with ammonia and ammonium and ammonium chloride. I think I am clear from my side, and I hope you all will have a nice day by studying this video. And a big thank you for watching, subscribing and liking my videos. Thank you.